My name is Bhupesh and we will talk about the PWM regeneration or the demodulation of PWM signal. Now in this topic, what is the most important thing is when we get the PWM signal, PWM is stand for pulse width modulation signal. These modulated signal needs to be recovered at the receiver side. So what is the method by which we can actually retrieve that particular signal? Now the first part is whenever we have the PWM signal, this PWM signal needs to be first passed through Smith trigger circuit. Now Smith trigger circuit, and after Smith trigger circuit, the output of this Smith trigger circuit will go through the RAM generator, and there will be adder circuit too. Now what is the role of this adder? After RAM generator circuit, this RAM generated circuit, there will be a synchronized pulse generator out there, and these two things, RAM generated as well as synchronized pulse generator, the output, actually this output is PWM signal will pass through this signal. Now it will be divided into two parts. This output of Smith trigger will first go through RAM generator, and the same output will go through the synchronizing pulse generator. Now in the adder circuit, both these particular outputs will be added. There will be a lift shifter which will actually done in this. Now when we can see this is the input signal, the normal input signal, where we have this. In the input signal, this is the PWM signal. This is the pulse width modulated signal. Now when we pass through a Smith trigger circuit, what will happen is the output of this kind is leveled due to this one. We can see this. The output of Smith trigger circuit is more leveled after passing through Smith trigger circuit. Now when we are passing it through RAM generator, the same output will go through two processes. The first output will be go through the RAM generator, the second one will go through the synchronous pulse generator. Now when this output will go through RAM generator, this RAM generator circuit provides this. So there will be an elevation part. Now whenever we are seeing this, if I are talking about this one, the level will remain the same, but output will be changed. This ramp will be generated. This ramp output will be generated due to this one. So whenever there is an extra width out there, the width of the ramp will be increased. Now what we can see is in above circuit, Smith trigger output, there is a gap between two pulses, but now that gap has diminished, completely vanished. And the second thing is this output of this RAM and this particular width of this particular signal will be determined by the above signal too. Whenever there is an increase or there is a higher width, the higher width will be there and output will be increased. When there is a lesser width, output will be decreased and lesser RAM will be there, as we can see through this signal. Now what is happening is the same output, Smith trigger output, will go through the synchronous pulses. Now synchronous pulse generator, what will happen is actually it will understand and it will determine the next level of that particular pulse, where this next pulse will be started, and it can be shown like this. Normally these sync pulses will have almost equal width in terms of their generation. Now both these, this one and this one, will be added in the adder circuit, as we can see it over there. Now in this adder circuit, this extra output will be added and it will be put over there. You can see it over there. This particular output of synchronizing pulses will be added to this. Now after this one, we will pass through the signal through level shifter. What is the meaning of this level shifter is it will determine the level of that particular pulses. because what we need to find out is what is the difference between the different pulsing. So whenever we are saying this, level shifter will determine, and same kind of width will be provided over there, and it is over there. Through this particular levels has been designed in such a manner where we can distinguish the different pulses. Different pulses can be seen in this particular output. Now at particular level, on this particular level, only output is the extra added output, which we have added in through synchronization pulse generator. This output will be there on the above side. Most of the part has been taken off and it has been brought down. Now this will be gone through rectifier circuit. The rectifier circuit actually will determine that the level which this level shifter has designed, a level shifter has determined, this level will be actually remain, this particular level will be remain over there, and the rest of the part will be eliminated after passing it through rectifier circuit. We can see it over there. After passing it through rectifier, this part, the lower part below this level, has been eliminated. Why we are doing this exercise? We need to determine that where are these pulses and what kind of width they are representing. Every time when we are seeing a different width, now in this width remains the same, but what is the difference is the amount of amplitude. The rectified output have different amplitude. So due to this we can see, or we can actually make this amount, this amplitude will be shown over there. So this amplitude will remain the same from this pulse, and whenever there is a high amplitude, the pulse will go up. Whenever there is a low amplitude, pulse will go down. So by this manner we can get this modulating signal. This is how this whole circuit, this demodulation of PWM signal has been done. Once again, Smith trigger circuit, first PWM signal needs to be given to Smith trigger circuit, then it needs to pass out through synchronization pulse generator as well as ramp generator. Both the outputs will be added, then level shifter will be there, and after passing it through level shifter, the rectifier circuit will determine a particular amount or level or above which this pulse has been eliminated, or this particular signal has been eliminated, and then after passing it through low pass filter, what we get is demodulated signal. Because demodulated signal will determine what are the amplitude variations which are available in these particular rectifier output. Now we have already gone through two parts of this. The first part was the PWM generation, and the second part was the PWM demodulation part. Now what is the disadvantage or the drawbacks of this particular method? As we know, the pulse width modulation is a very good method, but there are some drawbacks and there are some things which needs to be understood. So what are those drawbacks? Is the first drawback of this circuit of PWM is, in PWM, pulses are varying in width and therefore the power contents are variable. This requires the transmitter must be able to handle the power content. Transmitter must be able to maintain or handle that power content of a pulse having maximum pulse width. So due to this, every time we are seeing that the pulse width is different, because of if there is a change in amplitude, the pulse width will be changes. Now there is a changes in the pulse width. What will happen is, you need to understand that the power content will be different, and that extra level needs to be maintained by transmitter side. So that transmitter level needs to be maintained in this circuit. So this is the first disadvantage. Then the first was power content needs to be maintained. The second part, or second disadvantage of PWM signal, is the large bandwidth is required. Large bandwidth is required. So these are the two disadvantages compared to time signal. Now there will be a large bandwidth requirement compared to time signal. And what are the advantage? What are the advantage over time signal? Now the first advantage is, unlike PAM, lesser noise will be there. Lesser noise in pulse width modulation. The second one is signal and noise separation is easy. This is the very important point. So whenever we are seeing this, the separation of signal and the noise is quite easy, as we can use a particular circuit where we can check that particular amount of amplitude is there. We can just eliminate that in PWM. So noise separation is quite easy, because we are not talking about additional information is not there in the amplitude, it is in the width only. So that noise separation is better. And the third part is, in the PWM, is they do not require synchronization between transmitter, and this is a very important one. Doesn't require synchronization between transmitter and receiver. This is the most important point. In every signal generation, we need this part. The synchronization needs to be done between transmitter and receiver. In this part, in PWM, we don't need that synchronization level between transmitter and receiver, because what we are getting is already there is no extra amplitude out there. So what we need to do is, we just need to check it out pulse and its width, and according to that width the signals can be generated in the receiver side. So these three are the advantages of PWM, and these two are the disadvantages or drawbacks, or these things they are lacking. Now these things can be actually helped or eliminated over the period of time, and what we can do is, what we can have a better signal. Now in the PPM we have the better positioning of things, and better advantage can be achieved, and better signal can be achieved at the receiver side without any noise. So we'll talk about PPM, pulse position modulation. Now pulse position modulation is the evolved developed method to actually reduce the noise part, as well as that problems of PWM, pulse width modulation. The input is basically the PWM, pulse duration modulation or pulse modulation. Now how it is different from pulse width modulation? Instead of talking about just the width, in the pulse width modulation, what we are saying is, we are just maintaining that amplitude, but the width of particular pulses will be changed according to that particular modulating signal. Whenever there is a change in the amplitude of a modulating signal, the change will be there will be a change in width of particular pulses. Now in this scenario, if we are talking about this PPM, the amplitude and width will remain constant. Amplitude and width will remain the constant, but the position of these pulses will be changed according to modulating signal. That's why it is called pulse position modulation. Now but there is a problem in this. Whenever we are talking about the particular change in position, there needs to be a requirement of synchronization pulses. between the transmitter and the receiver side. Now this is the disadvantage of PPM. What we need to do is we need to have a synchronization pulse between the transmitter side and the receiver side, and that synchronization pulse needs to be sent from transmitter to receiver so that understand that where particular pulse has been ended or a particular signal has been ended, so that the position of that particular pulse can be determined. Now this is the one disadvantage of this PPM. So but there is one advantage as well, that transmitter handles constant power contained, and it is obtained from PWM. Now in the PWM, as we have already understood, that in the PWM, pulse width modulation or pulse duration modulation, the main problem was the power contained. It needs to maintain that much power to have a particular pulses maintained, and that power needs to be contained. In this, there is no power contained requirement, so transmitter need not to have this power contained requirement. So it is an evolved version of PWM. Now when we are talking about this thing, what is happening is each pulse of pulse width modulation, that pulse width modulation, modulated pulse, trailing edge will be the starting point of PPM. Now whenever we are talking about it, the trailing edge of that PWM will be the starting point of PPM. Now we can see this in this particular diagram. In the first part you can see this is the baseband signal. This baseband signal is there, which needs to be modulated. Now there is a sequential pulses out there. It is just the pulse generated, so that we can actually determine the various pulses, and the particular comparison level needs to be understood. Now whenever we are talking about the sequential pulses, the PWM signal will be generated, and if there is a change in amplitude, the width of these pulses will be there, as we can see in this diagram. Now in the last part, what we can see is the trail end of this one will be the starting of this pulse. Now this pulse actually is the pulse position modulation or modulated output. Now what it is showing is these particular pulses, whenever there is an ending time of this particular PWM output, it will be the start of PPM. Now how you can generate pulse position modulation? There must be a way. So what we can use is, we use differentiator and monostable multivibrator circuit for this thing. Now we can see this here. This PWM output will be used as an input to this differentiator circuit. Now this differentiator circuit will be passed through this capacitor C1. Now this will be passed through this circuit and to this monostable multivibrator circuit. Now what will happen is, whenever there is a pulse, if the pulse will have a different positive as well as negative spikes, and different positive and negative spikes in the pulses will actually change the input of this particular multivibrator circuit. Now the negative spikes trigger the monostable multivibrator circuit, this circuit. And what will happen is, monostable multivibrator circuit generate pulses of the same width and amplitude with respect to the trigger circuit. So whenever we have the positive pulses out there, this loop will be there and it will be determined by this. But whenever there is a negative pulse, a negative spike here, it will actually switch on this monostable multivibrator circuit, and what will happen is, we have this ending pulse at the time of this pulse width modulation pulse. Now what is there? This is the example of PWM pulse. Now these pulse width modulated output, you can see the width is changed over the period of time. Now what we are having is, trigger pulses will be there. This trigger pulses will be actually start this particular circuit. Now this trigger circuit is like this. Now there is a constant output, constant amplitude will be there, and this pulse is ended over there. Yes. Again the new pulse will be right. This is the positive spike. Again the same output, the same amplitude will be maintained till the time this pulse width modulated wave or pulse has been ended. Now whenever this is ended, there will be a gap, and again there will be the negative spike will be there, again a positive spike will be there. Now this negative spike, whenever it is going down, will actually trigger this monostable multivibrator circuit. Monostable multivibrator circuit will give the pulses, and this output will be shown over this pin, and this will be PPM output. Now whenever this negative trigger is there, it is brought down, so there will be a pulse of same width and same amplitude. You can see it over there. So this is how the PPM pulses has been generated. And the most important thing is in this particular circuit is the input of this circuit is the PWM or PDM. Again, I must tell you that PWM, pulse width modulation, and pulse duration modulation are the same thing. They were used interchangeably, and there is no differentiation between them. What we need to understand is, so this PWM pulses actually helps us to understand PPM, and this synchronization pulse will actually help us determine whenever this PWM pulse has been ended. So we need synchronization pulses as well as PWM for this. Now in the next lecture we will talk about PWM demodulation circuit. How PPM demodulation circuit, I beg your pardon, PPM demodulation circuit. In the PPM demodulation we will generate the same modulating signal from the PPM. Thank you guys. This we will talk about PPM demodulation circuit. In this circuit, as we already understood that we need to send a synchronization per circuit or synchronization signal from transmitter to receiver. Now this synchronization signal will help us to put a reference point where this particular signal or particular pulse has been started or ended. Now this sync pulse will be sent to a reference pulse generator circuit. This pulse generator circuit will be sent to a SR flip-flop, and the output of this SR flip-flop will be the PWM, pulse width modulated output. Now this output can be sent to PDM demodulator, which we have already studied, and we will get the modulated signal. It is quite easy as that. Now what is happening is, whenever this reference pulse generator will be there, so SR flip-flop will be set. Now how do we set this SR flip-flop? Now this SR flip-flop will be set based upon that particular circuit. Now PPM signal, this PPM signal will be actually provided to R side of flip-flop, and to the S side we will provide this synchronization pulse. Now this synchronization pulse will be sent. Now when it will be set, when this SR flip-flop will be set when the reference pulse arrives. Whenever there is a reference pulse from the synchronous circuit, from the transmitter, it will set this particular circuit. What will happen is, now this is the reference point, this is the trigger. Now whenever there is output, you can see here. Now whenever it is set, so the particular point at which this is the end of this particular signal. As we know that PPM is actually showing the trailing side of that PWM signal. So what we need to have is the reference point of that signal. So where it is ended is, this is the reference point, it will be ended here, and this is the point where it will be started. So this is the position where it started, and this is the point where it will end it. Again, this is the point where it started, and this point is where this PPM signal has been ended. So whenever we have this particular signal, pulse will be there. Actually we will have is, this is the trailing point of that PWM signal. So this is the trailing point. So we can draw it over there, and through this circuit we will get the PDM output. This PDM output can be sent to PDM demodulator circuit. We will get it. What we will get is the modulating signal. Now this is how the modulating signal will get from PPM. Now basically the advantage of this particular circuit is there will be a lesser noise. The power content problem of PDM has been solved in this particular circuit. In PPM we have a better signal synchronization. This is the disadvantage as well, because whenever we need to understand this PPM, every time we need to send a synchronization pulse from transmitter. So there is a extra requirement of synchronization pulse from transmitter to receiver. So this kind of thing is actually a disadvantage, some kind of disadvantage, but it will help us to get the proper signal. So this is the main advantage of this. And the noise reduction is better than PAM and PWM. Noise reduction is there, definitely. There is a lesser noise in this particular circuit. So PPM has a better noise capability. Another thing is the amplitude and width hasn't been changed in this circuit. So there will be less requirement in PPM than PWM and PAM. So it is the evolved version of that PWM. So we can say that it is the better version of PWM, and by this we can eliminate and reduce the overall noise content on this circuit. The next part we will understand is pulse code modulation, PCM. Here we are dealing in analog pulses, analog signal. Now we need to convert those analog circuits, analog signals to the digital signal. And why we are doing this activity? Because we need to reduce the noises, and what we need to do is we need to reduce that much of power which needed for that particular circuit whenever we need to send a particular analog signal from transmitter to receiver. There is large amount of power requirement in analog signals, and for this particular drawback or disadvantage, we will actually send this signal or convert this signal through a digital medium, and digital transmission will be there, but that will be done in the next class. Till now, thank you, and if you like the video, please like, share and subscribe my channel so that you will get this kind of video again and again. And if you have any questions, please let me know in the comment section. I will comment on this and I will answer to you definitely. So thank you.